Hi everybody. So applications of nanomaterial, that nanoelectronics we can see. Because the nano scale, so it's a very minute one. It's a very minimum one. Means it's a nanoscale. It's like it's a minimum size of particle. So nano means draft in Greek word. So it's a Greek word. Draft is the Greek word. So it is a 1 billion of meter of a meter. So 1 nanometer is equal to 10 to the power of minus 9 meter. So think of it. It is very small. So it is a very nano level. So 10 to the power of minus 9. So it is measure the nano-electron device. We can able to measure the help of nano-electronic devices. So it's a function of this small information about the nanoscale. So think of it. This is structure. It's a macro, it's a micro, it's a nano. So very minimum level, very the thickness and the level of material is very nano size, very minimum size. So nanoelectronics mainly used, it's an art of science, arts and science, and it's a manipulating the matter of nanoscale. So it's one of the major technology of nanotechnology is mainly it plays a vital role in the field of engineering and mainly electronics, mainly physics. Also, it makes use of the scientific methods and automatic scale of developing the nano machines. And also, the main thing is reduce the size, risk factor, and the surface area of the material and the molecules of the main target of the main functions of the nanoelectronics. And mainly, the nanotechnology, the field has been the subjects of intense. It's focused particularly from the viewpoint of the electronic industry because it deals with MEMS, microprocessor, optical switchings, and several applications in the electronic components. So it's the next level or next generation is mainly focused in the MEMS microprocessor and optical switchings. So these are the main components of the electronic devices. And why we are using the nano electronics in the sense it is the size and IC fabrications. Mainly we can use the two things. It's a physical size and the cost of the IC fabrication is decreased, is minimized one. So it can be the microelectronics is can be used to solve the most of the problem and the very small devices and it's overcome the limitations on the scalability and also the phenomenon of size and the mechanism is very reduced one is the main thing of the why we go for nanoelectronics. And history is 1959. The famous professor of physics Dr. Richard and P. Fan is found in the 1959 and it's developed in the days and also it is scanning is the scanning of tunneling microscope 1981 discovered the fluorescence in the emergency of nanomaterials and nanotechnology. Nanotechnology is mainly considered in the nanotech in the 1974. In 2000s, on the beginning, commercial applications such as nanotechnology, all those in the bulk applications in the nanomaterials. So Moore's law also it is mainly used in the main electronics field. So the designers is more used in the nanomaterials. And the main advantages reduce the size and the scale mechanisms, machines, and also its advanced properties of semiconductors can be determined. And also the molecular scale of nanoelectronics, also known as a next step of the miniaturization, because the size of the nanoelectric material is miniaturization of the electronic is a very important one. And at least the electronic theory and the research in the field of nanoelectronics is increases. And also we use it in the process of variability and they exceed the physical and the reliability of the limitation is increased. And also interface of the system generation integration technology in a single chip and the integration is different types of chips we can use in the single packages and the computers consumable less energy and a high speed and a high capacity of memory, and all of this circuit is more accurate than the atomic level. These are the main advantage of nanoelectronic materials. And why we use it in the industrial application in the main sense, it's the computer hardware we are using, display devices, mobile and communication product, and audio products, and the camera and films we can use in this consumer product in the nanotechnology. And the main example of the single electron transistor and the controlled electron tunneling and amplifying of current. There is a amplicity of the current, amplifier of the current, and the resonance tunneling devices and the quantum device used in the control circuits, the MEMS and the NEMS we are using. So the main industrial applications of the nanomaterials. And also there's a zinc oxide and the silver ion and aluminum silicate and the gold ion we are used in the different fabrication process and the material we are using. And this nanotechnology in the electronics mainly, we have n number of applications in the panel display, because it is flexible as well as the thinner than the current display plate, so we can use in the electrodes, and also use it in the fabrication of chips. We can use as the nanotechnology devices for the packaging process, and the nano wires and assembled in the glass thin films and the flexible plastics we are using. And also e-paper, where the displays in the sunglasses and the map, we can the car and the window seals, windshields we can use as a e-paper. And many applications, n number of applications we are using is the nanomaterial and the electronics and the nano. Thank you.